Let's continue to dive into the Fall Clarity Survey data. This week, we will still be in the use of the 4Cs domain, but focusing on critical thinking. Our data shows that 50% of educators ask students to reflect on their learning process monthly, and 29% ask students to do so weekly. Our digital portfolios in Bulb have been a valuable place for learners to add evidence of their thinking and reflection. However, 27% of educators report that they never ask learners to identify and solve authentic problems using technology. Developing critical thinking skills moves students beyond being consumers of information and into much deeper realms of thinking. Let's look at some ways thinking critically helps increase rigor and deepen learning. Conducting research about topics that interest students results in student investment in the work and the use of higher order thinking skills to integrate new and prior knowledge. A simple yet powerful way to incorporate research into your classroom is by conducting a self-organized learning environment. You can use the Start Soul app to develop an entire lesson plan in less than 60 seconds and then watch as learners use 21st century skills to develop their own understanding of content and concepts. Giving students agency in the design and direction of the problem framing and solving processes increases student engagement. Moreover, the abundance of variables within those processes creates myriad opportunities for learning. Learners can be guided to design their own learning through the use of open-ended templates, such as this argument-driven inquiry lab framework. Through the use of this framework, learners independently design their own lab experiment with guided support. Equipped with computing devices, we use our cleverness to tackle problems we would not dare take on before the age of computing and build systems with functionality limited only by our imagination. Do students have to learn to code to learn computational thinking? No. The computational thinking skills of decomposition, pattern recognition, abstraction, and algorithmic design can be integrated into any content area without designing and implementing code. Here are some examples of how to integrate computational thinking into your content area. Students analyze the classification of nouns and verbs. They consider nouns as a person, place, or thing, and verbs as action words. Then they run a group of words through a series of tests and identify instances in which this standard notion might lead to error. Students problem solve with Desmos to make predictions, look at data, and create models. Students study or create digital models of science systems and identify the advantages and limitations of the models. Learners create a population graph from data in a spreadsheet. Students can analyze, fill in, or change parts of the program. Learners examine the various aspects of music, such as scales, melody, and rhythm. The patterns they discover will enable them to modify an algorithm to improve the quality of the music generated by the algorithm. Let's get together to discuss critical thinking strategies and tools that can be used in your classroom.